Is Jericho gone?
Exponential root.
Chair is at the ortho.
So chair will.
That is not good. Okay.
No, it's okay.
Is she getting her?
She's getting
I
her
swear to
retainer.
God.
She's getting her.
I can't talk today. I'm done. He said it's just cheese.
Alright.
That's what.
There we go. Okay. A little bit of a delay.
You told other classes that we picked bad colors yesterday.
Yeah, I don't have time. Okay, so you want to see number one or do you not?
Yes, I don't know how to.
Okay, here we go.
The stuff that we did at first, but not yesterday, is the stuff that I don't do the most.
That makes sense. That's why we do a review day. All right, so just so you know, what we're trying to do here is we're trying to prove that if we have this, then this must be true. Now, I'm going to mess around with this before I start. You don't need to write this down. I'm going to show you what our goal is and why. So I'm going to mess with this because this is kind of confusing. And I'm going to take this, I'm going to multiply it over, right? I'm going to treat that all as a number. I'm going to multiply it over to get rid of the division. Are we cool with that? So what I'm going to get is E over F times quantity of B minus D. Again, in parentheses. I treated it all as one number because I moved it all over at once, right? We were dividing by a number, right? Whatever B minus D is. And so I just decided to multiply by that number. Cool. Now, if you look here, if I know what A and C are, if this is true, when I plug in A and C, like I substitute over here, right, and I subtract them, this should pop up. And when it does, I can just move backwards and get to here. That's my goal. So I'm going to find out what A and C are. And I want them in terms of E and F. Okay? So I've got all this. Let me write that down. This is given to us. So we have three ratios equaling each other, a triple proportion. So I'm going to look at A over B, and I'm going to get it in terms of E over F. So I can ignore this, right? Right? I can just take A over B equals E over F. I'm going to ignore that. And I'm going to get A on its own, because I want to know what A is. How do I get A on its own? Multiply both sides by B, right? Instead of dividing by B, I'll multiply. When that happens, I get A equals, now multiplication happens in the top and division in the bottom, right, for a fraction. So when I multiply by B, it's going to go in the top with E. Cool? So I found out what A equals. Now I'm going to find out what C equals. Again, want it in terms of E and F. So what am I going to do to get C on its own? Multiply by D. So it's going to go in the top with E, right? So C equals DE over F. All right, so now I know what A and C equal. So I'm ready to just subtract them and see what happens, right? So I'm going to say, let's do A minus C. Instead of writing A over here, I'm going to substitute what we found it to be equal to. What does it equal?
DE over F.
Thank you. And that should be minus whatever C is. What's C?
DE over F.
Right? And that has to be true, right? We know what A equals, we know what C equals, so this should be true, right? And notice this is really close to this, right? We've got all the right letters. So now I'm going to play with this. Notice they have a common denominator, right? If I had like 2/5 minus 6/5, right, I could combine those because they're both fifths, right? They're both F's. There's a joke to be made there. So when the denominators are the same, you just subtract the numerators, right? If I had 2/5 minus 1/5, that would be 1/5, right? If the denominator is the same, you just subtract the numerators. So I do BE minus DE in the top. Cool? So now what I'm going to do is I'm going to notice there's two E's there, and I'm going to pull that E out to get to here. So A minus C equals, in the top, E times B minus D. And that's going to look weird to you, but it's just reverse distribution, right? If I gave you this, you would know you could distribute E, right? And you get EB minus ED, right? The same thing we have here. So totally valid, as long as you can put it back, it's algebra, right? So both had an E, so when I pull that out, it goes here, and then it redistributes. That's where the two E's come from, okay? So when you pull out, make sure there's only one of them. And notice that this is just multiplication. E times whatever this is divided by F. Now multiplication and division, you can do it in any order you want. So I'm going to write it like this. I'm going to divide E by F first, and then I'll multiply by B minus D later. Totally fine. Totally
Over
fine.
F, right?
What?
Doesn't the B minus the D have to be over F?
Nope, because it's all multiplication and division. So if I had like 2 times 3 minus 1 over 4, right? I could rewrite that as 2 over 4 times 3 minus 1. And you know this is true because if you kept it like this, that's 2, right? What's 2 times 2?
4.
Divided by 4 is?
1.
1. So that definitely equals 1. Now, if this is the same thing, then what I did was legal, right? What is 3 minus 1?
2.
What's 2 times 2?
4.
Divided by 4 is?
1.
1. See? It's the same thing, right? You can do multiplication and division in any order you want. I just did the division first and left this multiplication for later, right? And so now that I'm here, right, I'm there. It's where I wanted to be. Where I really want to be is here. How do I get from here to here? What did I do? In reverse. I divide by this, right, to send it back over. So I'm going to divide, because that's multiplication, right? I'm going to divide by the quantity of b minus d. So everything over, and that's left over. So we win. Questions on this first one? Find out what a and c equal, and go, right? See what happens when you subtract them. I think starting like from here to figure out what your goal is kind of hard. All right, so I move stuff around to have an easier goal. So I found A and C and went to town. How do you feel? Okay?
In at the bottom part, like the
For last line, second to last where?
second to last,
Okay?
in the parentheses, is that a multiplication or?
That is a dot, this is a minus. Cool. I would highly encourage you to watch and not write, and then take pictures at the end. Because we're not going to get through all this, no way in hell. Just so you know. I'll turn up the contrast. I don't know why it's so dark. I think it's this thing that's dark. Actually, this is pretty bright. I don't know. Tell me when we're good.
Are you live or no?
Oh yeah. Great. So, the second lemma, not on your quiz. That's why it's not in the review guide. Also, it's the easiest one of the 3. They have the same height. Look, they divide, they cancel. Yeah, you're done, right? This one, prove cdeans are concurrent. So, or I'm sorry, we are given that these cdeans are concurrent, right? They do all intersect at G. And we're going to prove that means that when we divide up the triangle and go around in a circle, it equals 1, right? The ratio of the bases here, and the bases here, and the bases there, when they multiply together are going to be 1. This is Seebe's theorem, right? So, here's what we're going to do. Notice that these two triangles, triangle ACD and triangle BCD, they have the same height, right? And we know from our second lemma that if they have the same height, then their areas are going to be proportional to their bases, right? You guys remember that at all? So I'm going to call this one on the left the blue triangle. So I'm going to say area of triangle ACD over this guy, area of triangle BCD, because they have the same height, will be proportional to their bases. What's the base of triangle ACD? What little letter?
A.
Little a, right? And this guy, his base is?
B.
Little b. Cool. Now, there are other triangles that also have base A and base B and have the same height. If you look, these two triangles have the same height, right? So triangle ADG and triangle BDG have the same height, and they have base A and B, right? So they should be proportional to A over B. So I'm going to write that out. Area of triangle ADG that has base A, right? And area of triangle BDG. Cool? That's always true when the heights are the same. Now, we have a triple proportion, right? 3 ratios equaling each other. So we learned from lemma 1, the thing we just proved, that you can take 2 of these and do subtraction of the top and bottom, and it'll equal the middle guy, right? The other guy. So, by our first lemma, I can subtract this dark blue and dark green guy. and I can subtract the light blue and light green. And what I'll get is A over B. Cool. Now, we're almost done with the first part of this proof. What is ACD? ACD, you guys see it? This big triangle, right? Minus this triangle, ADG. Well, it's what's left over, right? It's this triangle. So in other words, that is just this triangle, right? So I'm going to write that out. We'll just do it in black. So this triangle right here is triangle ACG. Over here, BCD minus BDG. Well, BCD is this big triangle here. And if I subtract BDG, that's this triangle, right? What's left over is this triangle, BCG. Are you with me still? That's what that equals, right? So that should equal A over B. And that's what we want, right? What we're going to do is just what we did last time. We're going to get these things, the things that are on the left side of the equation, we're going to find out what they equal, so that when we set it up, we can substitute these things on the right side, and then things will go away, and we'll get 1. So we found A over B. Now let's go get C over D. Same dumb crap. Look at C and D, right? They have 2 big triangles associated with them, right? And they have 2 little triangles associated with them that have the same height. So when I subtract big triangle minus little triangle, what's left over is this guy, right? So that's going to go with C. And this is going to go with D. So I'm going to say, by the same dumb logic, or it follows, or whatever you want to say. By the same dumb logic, triangle ABG, its area over ACG is going to equal C over D. Now be careful when you write these that you match up the letters correctly. So ABG is this bottom one, and it goes with C, right? And this is the top one, and it goes with D. Make sure you're careful with that. I'm going to do the same thing for E and F. So E and F have these 2 triangles associated with it. Do you see those big guys, right? And they have the 2 small ones here and here. So big guys minus small guys gets these guys. So they're going to go with E and F. Are you seeing it? Okay. So this one's going to go with E. I want that on top. So I'm going to do this guy first. That's triangle BCG. So area of triangle BCG over this guy, BAG. That's going to equal E over F. So now I know what A over B is, C over D is, and E over F is. So I'm ready to set this up, put these guys on the right side, and see what happens. If you notice, I've got ACG in the top and the bottom here, so when I multiply, divide 1. ABG and ABG, sorry I didn't do alphabetical order here. Do you see that it's also ABG, right? Top and bottom, divide 1. BCG, top and bottom, divide 1, right? It's all going to be 1. So I'm going to write that down now. A over B times C over D times E over F must equal, A over B we said was area of triangle ACG over area of triangle BCG. C over D we said was area of triangle ABG times area of triangle ACG. Now I'm going to write this one in alphabetical order because I didn't do that before. That's my bad. E over F we said was area of triangle BCG over, I'm going to write that in alphabetical order, area of triangle ABG. And I think it'll be easier to see that these things go away, right? So now we do multiplication. Times in the top, divide in the bottom, right? So ACG in the top, ACG in the bottom, that's ACG divided by ACG. Anything divided by itself is 1, right? So that becomes 1, right? 1 over 1. What's ABG divided by ABG? 1. And BCG divided by BCG. 1 times 1 times 1 on the top, 1 times 1 times 1 on the bottom. What's 1 divided by 1? 1. So therefore, this equals 1. And we prove it. are you starting to see the triangles? Awesome. Take a picture or no? Beverage. Oh. I made this thing at 2 a.m. last night. I am tired and parched. Alright, serious business. Alright, see this theorem's converse. It says if you know that these all multiply to 1, prove that all of these CVNs actually do go through 1 point, right? Prove that they are concurrent. So we're going to assume that they're not, right? This is proof by contradiction. So, we're going to assume that they're not concurrent, okay? So let's say assume AE, BF, and CD are not concurrent. Right, we're going to assume the opposite and then prove that that's ridiculous, right? That's proof by contradiction. We're going to assume something really ridiculous is true, and then we're going to prove that it's ridiculous. Therefore, the opposite must be true, right?
This is the one I hate.
Right? So, we assume, just like in the diagram, that they're not concurrent. Now, it's fair to say that two lines intersect at a point, right? They're going to intersect at some point, right? All these guys do. We're going to prove that CD actually does go through CG. And the way we're going to do this is we're going to say, well, if CD doesn't go through G, there should be some line I can draw that goes through G, right? So, I'll draw it. I'll say, let CGE exist. Okay. So let there be a line that does go through CGE. So we know that this is true, right? We didn't assume that not to be true. That was given to us. We know A over B times C over D times E over F equals 1, right? So I'm going to say A over B, right, times C over D times E over F. That should be the same thing as AD times B over BD times BE over CE times CF over AF, right? The exact same thing. So, what do I want to do? I've lost my mind again on this one. Hold on one second, guys. I'm very, very tired. What we're going to prove is that this distance here between A and D, right, has to be the same distance between A and E. And we know that that's impossible, right? We know that A over B times C over D times E over F equals 1. So let's write that. A over B times C over D times E over F equals 1. But we know that A is the same thing as AD, right? Supposedly. And B is the same thing as BD. C is the same thing as BE. And D is the same thing as CE. CF and AF. Cool. So, if they both equal 1, then they equal each other, right? So this is true. But here's the deal. AE, right, and AD, those two segments right here, they should be equal to each other if this is true, right? AE is supposed to be A, and AD is also supposed to be A, right? They're both going to be that little a. So I can switch out AD for AE, right? Wherever I see A, yes, I can say that. So AE I'm going to write here. AE over BE times all the other stuff that stays the same. And we're almost done with this one. Cool. So you know AE and AD are the same thing as A, and BE and BD are the same as B. Well, if you look, if I divide CF over AF from both sides, right, anything divided by itself is 1. Anything divided by itself is 1, and what we're left over with is this times 1 times 1, which is just this. So what this is saying is that, look, AE over BE must be the same as AD over BD. Now remember, these are ratios. So it's saying the way we cut the triangle here, AE and BE, must be the same ratio as AD is to BD. So in other words, we have a line, and I'm saying, look, I'm going to cut the line here. Maybe it's cutting it into 2-to-1 ratio, right? Whatever the ratio is, I don't know. How can it cut it into 2-to-1 ratio like that and be a different point and also cut it into 2-to-1? Right? In other words, if I have a line and I cut it in half, right? Is there another point that I could choose to cut it at that would also cut it in half? No way, right? How can I cut it into 2-to-1 at two different areas? Doesn't make sense, right? So this is a contradiction. You can use that as a symbol for contradiction. You can use this as a symbol for contradiction. Lots of different symbols. This guy, right? This can't be true. So therefore, the opposite of what we assume must be true. So we're going to say, therefore, AE, BF, and CD are concurrent. Which means the CDNs are concurrent, or whatever they were at the top. Cool? So end with something like that. What are they right at the top? CBNs, these guys are concurrent. So CBNs, blah, 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 are concurrent. We're done.
I have a stupid question.
No, you don't. Continue.
Well, I was lost at the part where you said AD is the same as AE.
Mm-hmm.
I don't know where you got that.
So, hold on 1 second. So, we're assuming that there should be some line that goes through C, or goes through G, right? Right? But in order for this to be A over B times C over D times E over F equals 1, this ratio here would have to be the same as this ratio here. That's what we're showing. And that's not possible because we cut in two different spots, right? So I can't cut at E and call it A over B, and I can't cut at D and call it A over B, right? That doesn't work. If this is A, then that's not A, right? One of these things has to give. Now I know from the setup that A over D was little a, right? And I know from this, by Sivas theorem, right, that this should be A and that should be B. So that's where our contradiction is. Both of these can't be little a. Does that make sense? I know they have to be based on Sivas theorem, right? But they can't be. It'd be impossible for this to be true. Okay? 4? Oh, God. Bo. Yes, you may. All right. 4. Medians of triangle ABC are concurrent. So we're going to use Sivas theorem's converse. What we're going to do is we're going to prove that when we draw on our medians, that it's going to divide up the triangle into A over B, C over D, E over F, and that it's going to all equal 1, and therefore they must be concurrent. So let's draw some medians. Let's draw a median here. And medians are vertex and midpoint, right? So I'm going to call that AD. Exist. And let's have CD be congruent to BD. So first median created. Then we're going to connect this guy up. It's a very bad median, but pretend it is. We'll call it CE, such that AE and BE are congruent. Cool. Now, it is not crazy to say that two lines are going to intersect at some point, right? It's the third one that we're going to worry about, that saying that that one must intersect at this point here, right? So what we're going to do is draw another median and not assume it intersects there. Obviously, it would if it were an actual median. We know this to be true. They all intersect at the many-center, right? But we're going to assume it doesn't, right? So we're going to let BG exist, or BF. And we're going to have it so CF and AF are congruent. So I'm going to prove that AE over BE times BD over CD times CF over AF is all going to equal 1. And I'm ready to do that because I know what these pieces equal now. I've got enough information. This one's one of the easier ones. So I'm going to write AE over BE. Again, I'm just going around the triangle, right? Pick one to start on and go around it. BD over CD times CF over AF. And I'm going to prove that that actually equals 1. Well, isn't AE the same as BE? Right? So instead of writing AE over BE, I could write AE over AE, right? Because AE is the same as BE. Same thing with BD. It's the same as CD. So instead of writing BD over CD, I can write BD over BD. And instead of writing CF over AF, since they're the same, I can write CF over CF. And we win, right? Anything divided by itself is 1. So therefore this equals 1, and we're done. How do you feel about that one? Medians, by definition, bisect their sides, right? They create midpoints. And midpoints are congruent. Yo.
Can you go back to 3 so I can take a picture?
Oh, did we get a picture of 4 guys? Lindsay, did you get a picture?
Yeah.
Okay. You good? All right.
On the one we just did, do you have to draw the third line so it doesn't go through? Or like, could you?
Yes, because we're assuming that they're not concurrent, right? We can't prove that. It's not proof by contradiction or anything. We're just saying, look, we're trying to prove that they're concurrent, so I don't want to start out saying they aren't, right? So I just drew 3 medians and pretended they weren't, right? Cool. Triangle angle bisector theorem, tab theorem. So we're going to prove that when you have an angle bisector, which is what they gave us, right? AD bisects this angle. That the sides of that angle that you bisected must go with their bases. Now remember, we're not going to be able to prove that these two triangles are similar. Not going to happen. We only have one set of angle in both, right? We need double angle to be able to do that. So what we're going to do is we're going to add another triangle to this drawing. So you're going to pick one of your sides, X or Y, and you're going to draw a line that's parallel to that. So I'm going to pick side Y, which is this guy. I'm going to draw a line that's parallel to that. I'm going to call that CQ. And then I'm also going to extend this guy. Where they intersect, I'll call L or something. So let CLQ exist and ADL exist, right? We also want this to be parallel to this. So we're going to say that CLQ is parallel to AB. Totally allowed to do that, right? We can draw two parallel lines whenever we want. And we can extend a line whenever we want. Cool. So now what you're going to do is you're going to get alternate interior angles, right? That's what these parallels are for, right? If you look, we have parallels, transversal, right? The brown. So alternate interior are these two guys. You guys see that? Alternate interior? Are you with me on that? Same, or inside the parallels, right? Those two angles are inside the parallels. And they're on opposite sides of the transversal. Yeah? Better? Okay. So, by alternate interior angles theorem, angle DAB is congruent to angle CLD. Now, it's one set of angles that's going to get these two guys to be congruent, right? Or similar. Where's my other angle that I can get, set of angles? Vertical, right? Here and here. So by vertical angles theorem, angle CDL is congruent to angle ADB. So now we have two sets of angles, and if we have two sets of angles, that means that these are similar triangles, right? By angle, angle. So I'm going to write that by angle, angle similarity. Triangle ABD will be similar to the other triangle. Now let's match them up. A is going to go with L, right? B will go with C because we don't know them. And then D goes with itself because of vertical. Now, great news. If they're similar, their parts are going to go together, right? A and B, which is what we want. And then Y should go with this side. But notice we don't know what this side is. We want it to be X, right? How do we prove that this side is also X, just like this guy? Do you see it now? Isosceles triangle theorem. Converse, right? That's an isosceles triangle because two angles are the same. So this and this are the same, which means this is up. So by isosceles triangle theorem converse, because we started with the angles, right, and got the sides, we know that AC is congruent to CL, which means CL must equal X. And now we're going to do CSP. All right, moving down. Let's do CSP. By CSP, AB over LC equals BD over CD equals AD over LD. Well, we know CL is the same thing as X, right? And AB, according to our diagram, AB is Y. So it's Y. BD and CD. BD, little b, CD, little a. Now, AD and LD I don't care about, right? Because that's what I want. Now, how do I get that to look like this? What's the last step? Flip them both, right? And I win. So, key here, alternate interior, right? Get your triangle similar and know that this is a giant isosceles, right? Extend your lines. See, take a picture? It's right there.
Can you go to 4 so I can take a picture of that?
Take a picture for it? Yeah. Everybody done with 5?
I didn't know that.
Big isosceles triangle.
Oh, that one.
Yep. 4. All right. Page 6. Prove angle bisectors are concurrent. So we're going to use angle bisector theorem here. If we have this, then we know this, right? By angle bisector theorem. So when we draw our angle bisectors, we're going to use that to get A, B, C, D, and E, F all together, right? So let's draw in some angle bisectors. So I'm going to say let AD exist. And you can write B the angle bisector of CAB. Or you can just write that let CAD and BAD be congruent. I don't care. I called it the angle bisector of CAD. It's up to you. You can either tell the two angles are congruent, or you can tell me that it's an angle bisector. Either way. I'm going to do it for this guy as well. I'll call it BE. Quotation marks means just what I said above with slight change. Does that make sense? You can use that as a shortcut if you'd like on your quiz. Same thing as above, just with a change, right? And I'm going to do this guy as well, right? Now we're not assuming they're concurrent. My line just happened to be concurrent. We're going to prove that they are. So let CF be the angle bisector of angle ACB. Cool. So if you look, let's look at this angle here. It's an angle bisector, right? Just like this guy. So we know the sides of our triangle should be proportional to the bases. Yeah?
So what are the parentheses?
These quotation marks,
Yeah.
it just says same dumb thing as above.
Okay.
It's this. Does that make sense? It's really good shorthand for filling out time cards, guys, when you get older. Right? You work the same hours every day. Don't have to write 8 to 3. Do that, right? So, this is an angle bisector, which means these sides should be proportional to these bases. So, by angle bisector theorem, triangle angle bisector theorem, tab, right? By tab, we know that AC over AB equals CD over BD. Right? The sides of the angle we split are going to go with the bases. We okay with that? I'm going to do the same thing for all the angles. So sides of the angle I split, that's AB and BC. They're going to go with their bases. AF or AE and CE. And then the blue angle, AC and BC. They're going to go with their bases. So AC goes with AF and BC goes with BF. So I want you to notice, I didn't do the little letters. You can do that if you want. You can say let AF be little a and let BF be little b, etc., etc. I didn't want to do that because it's more writing. I'm going to prove that AF divided by BF times BD divided by CD times EC divided by AE all equals 1. Okay? And now I know what things are, so I'm just going to set it up. So I'm going to write that AF over BF, just going around the triangle, right? This times this over this, BD over CD, times CE over AE. I'm going to prove that that equals 1. And if it equals 1, then they're concurrent, right? So what does AF over BF equal? Didn't we find that earlier? What does it equal? AC over BC. Okay. What's BD over CD equal? Be careful, it's flipped. AB over AC, very good. Are you seeing where this is going? Right? We're going to have things cancel. CE over AE, we know equals BC over AB. And if I did it right, everything should cancel and become 1. AC divided by AC is 1. AB divided by AB is 1. And BC divided by BC is 1. This is why it's important to write in alphabetical order. It's easier to see if they cancel if they're the exact same thing, right? So all of that is 1. So by Sieve's theorem's converse, it says if we have this equaling 1, right, then they're concurrent. So I'm going to say by Sieve's theorem's converse, angle bisectors of triangle ABC are concurrent. And we're done. So, take a picture if you want. We got all the angle bisectors, right? We created them. Then we said by triangle angle bisector theorem, tab, right, this thing, these guys all equal each other, right? The sides of the angle go with the bases. and then I set it up and knocked it down. Almost all of our proofs for concurrency, for the Sevians, right, are going to be prove that this equals 1, right? Prove that when you go around the triangle, it gets you 1. And after that, you win by seeing this next converse. Moving on. Cool. Perpendicular bisector theorem. All right. So it says D is perpendicular bisector, right? Prove that it's the same distance from A and C. Well, first off, we're going to draw in these lines so we can prove that it's the same distance. That is a really good straight line. So let AD and CD exist. Right? You can totally connect the dots, so it's valid. Now we're going to prove that those two blue lines that I drew are congruent. And the way we're going to do that is prove these two triangles that I created are congruent. Well, I've got a side and I've got an angle, right? What else do I got?
The shared side.
Yep, thank you. BD is congruent to BD. So now what do I have to say the triangles are congruent? Side angle side, ABD. Triangle ABD is congruent to triangle CBD. Nice. And if they're congruent, then their parts should be. So we're going to do CCP, right? Corresponding congruent parts, about similar. AD and CD. AD, CD, yep, they're corresponding. So AD is congruent to CD. Therefore, by definition, D is equidistant from A and C. How does that one feel? D, it should feel like quiz 2, just drawing in your own lines. And then, of course, definition of equidistant means it's the same distance, right? Distance.
Is there gonna be a number 14 on the test? Can we do that, please?
Would you like to skip 8? I don't know if we have enough time to do number 14.
Oh.
What even is it?
Good news, bad news, guys. Oh, hold on.
Wait, I don't even.
You guys got homework yesterday. Like number 14?
Oh wait, yeah, I do.
Just got it.
Or 11, or 12, or 13, or
Okay.
14.
Oh, I never did that.
What must G be?
Circumcenter.
In center, right? Because angle bisectors, circle inside, right?
So good.
Now, radii, when we measure to the side of the triangle, don't they always measure at 90? So that's a 90, and this should be a 90 as well, right? So, how can we figure out what y is? Well, this is a 90-degree triangle, right? A right triangle? So if I knew what this is, then I can do p tag to figure out this. Well, this is a right triangle. So I can figure that out. I do 5 squared plus root 21 squared, and I get this, right? We'll call it C, this length. That's 25 plus 21. That's 46. Rooted after I cancel here, right? So this is root 46 all the way across. And if you're clever, you'll realize these triangles are congruent, right? They're both right triangles and they have the same hypotenuse and the same leg. So if this is 5 root 21 and root 46, and this is 5 something and root 46, what is y? What's y gotta be? Root 21, right? Now you can do p tag again and figure that out. That's what y is.
Wait, how?
These two triangles are congruent because they have hypotenuse leg. You could either do p tag again and figure out y, or you could just be like, look, congruent, right? That's gonna be root 21. X. This is a dot in the circle. You had homework yesterday that I gave you, which we didn't have time for because you guys took forever to get through the thing. That's a radius too, right? So that's 5. So radii are at 90. If we can figure out what this is, we can figure out what x is. Isn't this a 90-degree triangle too? So if I do 5 squared plus 12 squared, and root it, I should get this side, right? Spoilers, 5 and 12 are a special right triangle. That means this is 13. Trust me on that, okay? 25 plus 144 is 169. Root of 169 is 13. If this is 5 and 13, and this is 5 and 13, these triangles are congruent, right? So what's x? If you know what sides are, or if you know what centers you have, they're not that bad. If you want help with all those, I can tell you in numbers.
Can I come in 6th hour?
Would you be busy next hour?
You can also, if you have a study hall, come in during any of my geometry classes. I teach first, third, fourth, and sixth. You can also watch the videos online. My plan tonight, if I'm not swamped like crazy with people being here, is to record the whole packet, so it'll be up online. Okay?
Wait, are you busy next hour or this hour?
No.
Can I come in?
Mm-hmm.
Can I have a pass? I'm leaving my stuff in here. I just want to do the rest of them that we didn't.
There are very few on the last 4 or so that'll be on there.
Okay.
I also have a secret surprise I have to tell you guys about, but I'm not doing it yet. Mm-hmm. Study, study, study.